So in this video, let's talk about how to draw the lowest structure of actually ammonia. So ammonia is one of the most basic organic molecules that you'll be using throughout, whether it's your general chemistry career, your organic chemistry career, or in grad school. It's very important. So let's talk about how we would draw the lowest structure for ammonia. So the first thing I'm going to do is write out my atoms and the amount that I have. In this case, I have 1 nitrogen and I have 3 hydrogens. Now, from the periodic table, this is where I'm actually going to get the number of valence electrons, right? And so if you look at the periodic table, you should see nitrogen, and beside nitrogen to the right, you might see oxygen, and to the right of oxygen, you might see fluorine, etc. Now, everything in nitrogen's column has 5 valence electrons. Again, you can go ahead and revisit that topic about how we come up with the valence electrons on the channel. So knowing that nitrogen now has 5 valence electrons, we need to figure out how much valence electrons hydrogen has. And again, if you go about the periodic table, in that first column on the left where our hydrogen is at, everything in that column corresponds to 1 valence electron. So hydrogen in this case should give me 1 valence electron. Now the only thing I'm going to do now is calculate my total electron, or the total count. So this would be 1 nitrogen, which would be 5 electrons, but then I have 3 hydrogens, each worth 1 electron apiece. So that means this is pretty much 3 times 1, which is 3, plus 5. So this will give me 8 electrons that I have to place total. So with drawing Lewis structures, usually the atom that's furthest to the left in the molecular formula goes in the middle, and that's a convention most of the time, right? Not all the time, right? So for example, like something like water, right? Hydrogen is not the atom that goes that becomes a central atom. So, but most of the time, usually the atom that's furthest to the left or the first in the molecular formula becomes your central atom. So at this point, I could actually go ahead and place 3 hydrogens around the ammonium ion, and with the John Lewis structures, the first thing I typically try to do is form single bonds, simply because they're the simplest bonds I can actually form, right? So I'm not going ahead of myself, getting ahead of myself. I'm starting from the basics, right? So with all Lewis structures, well, not with all, but most of covalent structures, we have to have at least a single bond. So that's a good way to start. So in this, let's count the total amount of electrons we have used thus far. So this becomes 2, 4, 6. Now remember, nitrogen is one of those molecules that have to satisfy the octet rule. So at this point, we have only 2, 4, 6 electrons around nitrogen. Remember, each single bond worth 2 electrons, right? One, in this case, one coming from the hydrogen, one coming from the nitrogen, and vice versa, right? So we've placed 6 electrons thus far. And we know that hydrogen only has 1 valence electron, so it will never satisfy the octet rule. In other words, hydrogen can only form 1 bond because it has 1 valence electron, right? It only has 1 valence electron, so it can only form 1 bond, right? So knowing that hydrogen, we can't put any more electrons around hydrogen, and we've used 6 electrons out of the 8 that we need to place, the only other place for me to put my other 2 electrons would actually be on the central atom, and this would be the lowest structure for ammonia.